Okay, we're on effect number 55, which is the stereo vibrato, and it is the first of our modulation and pitch shift effects. Here I have a blank instance of HD1, which we'll use to explore the sound. I'm going to go into the oscillator and switch to a sawtooth, number 1086, because I think that just makes it easier to illustrate this effect. So let me route to insert effect 1, and then for insert effect 1, of course, I will choose number 55, which is the stereo vibrato. And let's turn it on and look at the unit. So the first thing that I want to point out is it's called a stereo vibrato, not because it imparts stereo information. It doesn't give the sound any more width than it had. It just preserves the stereo signal. That is, it doesn't sum it to mono. So you'll still have things that you had on the left, stay on the left, and so on and so forth, instead of just having a signal that's processed down the middle of your stereo field. So we have three boxes here: Autofade, Lfo, and Vibrato. The Autofade, I think, is new. We may have seen this in some other effects, but I'm pretty sure that it's fairly new. In fact, I think there might be there's like auto flange and stuff. Let me check those real fast. Stereo flange, envelope. Yeah, let's see if we have like an envelope phaser. Yeah, no, that's based on yeah, it has a control. It's very similar, except it's using an envelope, but it's a little bit different. So anyway, let's discuss some of these parameters. So starting with the LFO section, we have a waveform which lets us choose a sine or triangle. The sine wave is actually a triangle wave, and the triangle wave is actually a square wave. And then we have this shape parameter here. So to illustrate what this thing is doing, obviously this LFO is going to be patched into pitch, right? Except this effect is not, there's no way to really change pitch of a sound outside of like a sampler. So what this does is it actually modulates a delay. So that's what this effect unit is. It's a delay with the delay time being modulated by this LFO. And so let's hear what it sounds like. I'm going to go ahead and switch this to dynamic modulation. I'll take down my amount just to initialize anything, even though it doesn't matter since I don't have any sources plugged in. I'll put my depth on full 100, and we're at all the way wet. So let's give this a listen. I'll increase the frequency of the LFO that's patched into pitch. So that's very similar to grabbing an LFO like a triangle and patching that into the pitch of our oscillator. If we wanted to hear that. So there's a key difference between the way a synthesizer is doing it and the way that the vibrato is behaving. With the synthesizer, we don't get any change in modulation depth with increasing the LFO hertz value. As we speed up the frequency of the LFO and the vibrato, though, we do get more depth. We get more pitch shifting going on. So again, to hear that, we're getting very little pitch shifting there, but as I increase it, it increases dramatically. And again, if you want to hear the difference between a regular LFO, it doesn't matter how slow this is going. I need to give it some depth. It's still going the same distance, no matter if it's going at a lower frequency or a higher one. And that's just the way that it works with delays, because the faster you shift the delay time, the more pitch shift effect you're going to get. So let's talk about the shapes. Like I said, the sine wave is actually a triangle, and the shape parameter works just like the shape parameter on our regular LFOs. That is, with higher shape, we spend more time at the higher end. Lower shape, we spend more time at the lower end. So let's hear what that sounds like. Go to pitch, take off intensity there. Also, I am really annoyed by the volume of this, so let me turn that down. Much better. So let's listen to that. Spend more time at the higher end versus more time at the lower end. It might be a little bit difficult to hear. Let me turn down the depth and increase the frequency. Lower end, higher end. So that's pretty easy to hear. We do hear some strange artifacts going on, and I'm not exactly sure what's happening with that. I think maybe the LFO is getting clipped, but I'm not sure. So let's check out the triangle. This triangle is actually a square, so let's listen to that. So it's really easy to hear. If we compare that with like a square wave in our LFO, it's really obvious. Speed that up. Bring that back down to 0. There's the depth. Very similar. The shape parameter on this one is actually changing the slope of the square wave values. Let me make a little drawing to maybe make it a little bit easier to understand. So usually with a square wave, we're getting a high value and a low value, and that just repeats. When we change that slope parameter, we're changing the slope of these values. And then if we were to make it all the way in one extreme or the other, we get a straight up saw wave that will repeat. So let's listen to what that sounds like. Don't save. So we hear a downward trend, right? But we also still have that jumping between the two pitches. Until I go all the way in one extreme, and then we just get a single downward slope. And hearing the jumping. And then, of course, if we go the other way, we get a saw up instead. Yep. Vibrato depth just compensates for the. You can use this to compensate for the increase in depth as we increase the frequency. So, like if we're at like a high value here, we can decrease the depth. And now Autofade, which is the crowning jewel, I guess, of this effect. What this is going to do is it's going to allow us to have a control source. In this case, I'll just use gate 1. And then we have these rate and delay parameters, and these are the same as the fade and delay parameters on our LFO. The difference, though, is that these parameters are controlling essentially the volume of the LFO, where this is controlling the rate of the LFO. So the higher the rate is, the faster the transition is once this source is engaged. By the way, no matter which source you use, it's always going to act like a switch. So don't expect it to like scale to values from like JS plus Y, for example. So I'll just use gate 1 with a rate of 100 means it's going to switch instantly. If I take the delay time all the way down, it's going to speed up the LFO by an amount that is designated here. So let's try that out. Let's go down to like some low value, sure, 1.64 hertz, and let's go up by a significant amount. When I hit a key, we're pretty much just going to instantly hear 1.64 hertz plus 620, which is, I don't know, 7.84 hertz. So let's hear what that sounds like. Let's switch it back to a sine wave just so it sounds more like vibrato and bring down the amount a little bit. Bring down the depth. So it instantly goes into that vibrato, right? But if I change the rate and I have it lower, then it'll take longer to speed up the LFO. Now going back to having it instant, if I have some fade in, then what this does, it doesn't actually fade in. It just delays the amount of time that it takes for the signal to engage. So I can go all the way up to 2,000 milliseconds or 2 seconds. And again, that's just like this parameter here. And now when I hit a key, it'll take 2 seconds to go from 1.64 to instantly change to, what was it? What is this? Whatever 4.9 is plus 1.64. Nice. And we could use a bunch of different control sources and have it sound nice. So one other thing that's nice about this is we can kind of use it as like a chorus because we have this dry wet. Let's hear what it sounds like as a chorus unit. Sounds pretty good. Let's put the delay at 0 so it engages instantly, but then let's slow it down. Let's hear what this sounds like. Lower the depth. And we can also patch in like JS plus Y to a bunch of these parameters, which I think would sound nice. So we have JS plus Y. Let's go with a depth of 56. And let's also patch that into our dry wet. JS plus Y. Let's go with negative 33 so it gets more dry as I go up with the joystick. And let's, we can use JS plus Y as a source, but like I said, it's going to act like a switch, so we might as well have it as a dynamic modulation so it actually scales to the value of our JS plus Y. And let's hear what this sounds like. It almost kind of sounds like a rotary speaker for an organ or something like that. That's pretty much everything there is to know. I guess one thing that I didn't mention is that if we have MIDI tempo sync, obviously it's going to take away our frequency modulation parameters, just like it works on our regular LFOs, where if I have MIDI/tempo sync on, it's not going to let me modulate the frequency. Similarly, if I go to a common LFO, it's going to adopt the frequency of the common LFO because that's the point of the common LFO, is that it syncs up between different effects. And that's, I think, everything that there is to know about this unit. So thank you for watching. Bye.